Hello, I'm David Colson. I'm doing Mech 116 Lab 2. The prompt for this lab is that we have an AC motor and all the markings for the wires have come off, and we need to take these 9 leads from the motor and sort out which one is which. Each lead has to be connected a certain way in order for this motor to operate properly. So to understand how we do this, first we need to understand what's going on inside the motor when it rotates. So, inside the motor, we have 3 main windings. We've got A, which moves on both sides of the motor, B, and C. Now, A is moving positively in this direction towards us. So we've got a eddy current going a specific direction. And in fact, this is a symbol for not A. So whatever A is doing, this is doing the exact opposite. So when this is fully positive, this one's fully negative. And when this one's 0, it's 0, etc. So in order to get this rotor here in the middle to rotate around the stator, which is the different windings, we need to have all of the windings go positive to negative in series. So it'd be positive, 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 positive. And that will attract the north side of this around in the circle. And then also, the one opposite it will be doing the exact same thing to the south side of the rotor. So that's how our motor moves. So, in order to understand how it's wired, usually when the motor is wired, we have different coils inside of it. We've got coils A, B, and C that are connected to specific leads. So the top side of each of these coils would be 1, 2, and 3 on a 3-lead motor. On a 6-lead, you could have access to 1, 2, 3, and also 4, 5, and 6. When we want to be able to adjust the power of a motor between low and high, we add in coils D, E, and F, and they can go in series or in parallel to A, B, and C. So essentially, we would have A and D here, B and E here, and D and F here, along with their corresponding not values on the other side. They can go in series to amp up our motor, or they can go in parallel. So, not getting too ahead of myself. So we're going to see how these lay out inside the motor. So how these would connect in a Y or star type motor would look something like this. We'd have lead 1 come in. For a series, we would just have them connect straight down, straight up this way, and straight up that way. You can see the connections that are supposed to go on all 3 sides. One thing that's been determined for us is that instead of having 12 leads and being able to connect these how we want to, these leads were connected inside the motor for us. So we don't have access to 10 or 11 or 12 on this motor. So, in order to wire this properly, we first need to test and see which wire is which. We're going to see specific connections inside the motor. If we were to pull out a multimeter and test them, that these 2 are connected to, that we have 3 pairs, and we have 1 triple pair, or 1 triplet. We'll notice a ohm value of X across the 3 pairs that will tell us that it's going across 1 coil, and then any combination of these ones and the triplets will show 2X, because each of them have to go through 2 coils. So once we've determined that, then we can set up our O-scope and start testing to see how they're connected. When we put a analog signal along one of the pairs, what's going to happen is we will energize the second coil through induction. Essentially, because we've got an electromagnetic wave, because we're generating eddy currents in this coil, these coils are right next to it, so we'll see eddy currents there as well. So we can put we can take an oscilloscope after we put the signal in and check to see if what wave we're putting into the first set. So if we connect the positive and negative leads of the AC current, we can read the AC wave on 1, and then if we come down to 7, we'll see the same AC current. If we were to look at the AC current on 4 versus 7, we will see this. It's going to be, our signal is going to be inverted or 180 degrees out of phase on the bottom lead of coils 4, 5, and 6. And that's how we can determine or differentiate coils 1, 2, and 3 from 4, 5, and 6, and 7, 8, and 9. So doing this, we can tell what our first lead, our second lead, and our third lead are. So now that we know that, we can start hooking these up. So for our wiring process, in order to make a series circuit, we're going to connect together 4 to 7, 5 to 6, and 6 to 9. And we're going to put in L1, L2, and L3 for our currents. This is super simple. If we were to try to put it in a high connection, we would want to basically put these in parallel, and what that would look like is we connect 1 to 7, 2 to 8, 3 to 9, and we connect 4, 5, and 6 together. So what this does is, when we put our main current in, forgot about the step here. When we put our main current in, what we're going to see is that each one of the main phases has 2 paths through the stators to affect the rotor. It's got the first path through the coil connected to 7, and a second path through the coil connected to 1 and 4. We've got a neutral point in the circuit here, and we've got a neutral point in the circuit between these 3 points as well. So that's how we do the configuration for each one. So the next step is, once we've set up our 3 phases in the correct sequence, we will have the phase associated with the correct start of the coil and end of the first coil, and the first start of the second coil. Putting all those in series is vital to actually making it turn properly. Once we have all 3 phases hooked up, the one thing we don't know is which series is which. So we don't know if this is the 147 series, the 125 series, or the 369 series. But when we turn it on, one of 2 things is going to happen. It's either A, going to turn properly clockwise, or there's a 50% chance that it's going to turn counterclockwise. If it turns counterclockwise, we simply exchange 2 of the leads, any 2. We can do 3, 2, or we could do, for example, 1 and 3. Any change in 2 of these leads will cause it to spin in the opposite direction because you reverse the sequence. If we were to read it backwards, if we read left to right now, it would be 3, 2, 1, 3, 2, 1. This would be 1, 2, 3, 1, 2, 3 would be the sequence. If we flipped these 2, when we started here, we'd be reading 3, 2, 1 because we just flipped 2. Let's say we flip 2 again. Now we've got 1, 2, 3, 1, 2, 3. So reading left to right, we always flip the sequence when we replace two numbers there. All right, and to show that I've done this properly, if we come back over to our motor, which is properly configured, and we flip our power, we see that the motor rotates in the correct direction. That's all.